Hello students and friends, welcome to my YouTube channels. Today we are going to solve the heat transfer problem. Unit 2 convections problem. So as we know, two types of convection is there. Natural convection, forced convection. Natural convection means due to the density difference if fluid will flow is known as natural convection. If we have to apply the force, due to the force fluid will flow is known as forced convection. So today I am taking the forced convection problem. How will identify the force convection problem? If velocity will be given in this question, that means this problem will belongs to the force convection problem. This way we can identify. This is the trick here. Velocity is given, force convection problem. Then what are the steps to solve the questions? That steps I will discuss today and solve the problems. So very simple, looks very long, but very simple. If you understand, very simple, because all those things I wrote here, this is there in the data book. For UG students, data book allowed in the exam. So all the formula will be there in the data book. Only you have to identify which formula where you have to apply. And competitive exam, GATE exam and all, in the questions itself, they will give this value and all. So you have to just substitute and get the answer. So, okay, so now I will explain the steps first. So force conversion, what is steps? First we will see the velocity is there. Yes. Then this is the force conversion problem. They will check the film temperature. That is called surface temperature and fluid temperature. Average will take, it will get the film temperature. With the film temperature, we will take the all the properties like kinetic viscosity, thermal conductivity, Prandtl number. These are the velocity we will take from the data book at film temperature. Then we will check the fluid status. How we will check the fluid status? We will see the Reynolds number value. U L by nu. U is velocity, L is length, nu is kinetic viscosity. This value will substitute. If this value is coming 5 into 10 power 5 less than, is known as laminar flow. If it coming greater than, this flow is known as turbulent flow. So that way we can find the status of the fluid. Suppose flow is laminar. So now I am giving the laminar method only. The turbulent method will go the later on. So flat laminar flow. What is the stage for the laminar flow? First we will see the local Nusselt number formula from the data book. So NUX equal to nothing but 0.332, Reynolds number power 0.5, Prandtl number power 0.333. So we will get the local Nusselt number. Once we will get the local Nusselt number, again local Nusselt number formula will be there HXL by K. HX is local heat transfer coefficient, L is length, K is thermal conductivity. We will substitute the value here, we will get the HX, local heat transfer coefficient we will get. Now, average heat transfer coefficient for the flat plate formula is 2 into HX. Here carefully listen, for flat plate, average heat transfer coefficient will be H is equal to 2HX. Now, heat transfer what is? HATW minus T infinity. So, look this one questions I taken. This 5, 6, 7 in this questions not there, so I will explain. If they will continue, this also we have to calculate. We will explain now itself. So now look one questions I given like demo. Air at a 20 degree, air fluid temperature is 20 degree. At a pressure of 1 bar is flowing over the flat plate of velocity given 3 meter per second. That means velocity given, this is known as force convection problem. If the plate is maintained at 60 degrees Celsius, so that means plate temperature is 60 degree. Then they are asking calculate the heat transfer per unit width. So Q they are asking, where width is they given 1 meter. Per unit width means width they given 1 meter. And length they given 2 meter. So data what is given here? Surface temperature, this is plate surface temperature, fluid temperature, velocity, length they given. So this way we have to find the Q. So look here, just the steps. I am coming from the where I have to reach first. Q is equal to HA TW minus T infinity. This we have to reach. How will reach? H is unknown only. A means area. Area width into length. So width into length, that is called 2 into 1. We will get the area. TW T infinity given. If you know the H, we can solve the heat transfer. That what this question they are asking. So what is H here? Average heat transfer coefficient nothing but 2 into local Nusselt number to local heat transfer coefficient. So H will get. Hx how will get? Hx will get from the local Nusselt number, Hxl by k. So from there we'll get the Hx. Then local Nusselt number how we'll get? See here 0.332, Reynolds number power 0.5, then Prandtl number power 0.333. So this is what I wrote here, 0.322, Reynolds number power 0, Prandtl number 0.5. If this is the steps 1, 2, 3, 4, we can get the answer. That only steps I wrote here. So before this, check the fluid status. Each and every problems we have to do that work. Then once laminar, this is laminar only. Turbulent flow will come. That will be the different formulas. Nusselt number formula will be only different. So this is the steps we can solve this question. So now look here. This is the 10th edition data book. This is the 10th edition data book. Edition number 6 is there, 7, 8, 9, whatever any data book we can use. If you want to write the property, if you go to page number 45 in this table number, editions number 10th edition 45. See 6, 7, 8, 9, whatever edition is there, 1 or 2 page number will be vary for this. So this just get the idea how to see this value. So properties value of the gases at 1 atmospheric pressure, so all value they given. See this temperature they given, this temperature is known as film temperature only. Now here density if required will write, then kinetic viscosity required, this is the kinetic viscosity. If thermal diffusivity needs, that will take, this Prandtl number needs, that will take, specific heat needs will take, thermal conductivity needs will take with the film temperature. Here temperature, so all the temperature minus to plus C, all the film temperature is there. With this film temperature we'll get the value from the data book. Then 125 page we have all the formulas, page number 125. Now flat plate, see here, flat plate, film temperature TF into TW, T infinity by 2. Flat plate laminar flow. This is all the formula given here. This formula only I wrote there. This what formula you are seeing here, this formula I wrote here. So UG students will use this data book and you can solve the question. You have to only understand. Now look here. These questions I will solve step by each. So this is the steps you now you understand. That only I will solve with the all the values. So first steps what is? In this question, first steps will be film temperature. Film temperature TW. How much TW here? Directly I am writing 60 plus 20 by 2. So 40 degrees Celsius. We know the 40 degrees Celsius. Now from the data book, at 40 degrees Celsius, we will find the all the values. See this Prandtl number how much? 0 point already value I taken. So I will write now. Prandtl number value will be 0.6699. Then thermal conductivity value will be there 0.02756 into 10 power minus 3 watt meter Kelvin. This is unit of the thermal conductivity. Now thermal kinetic viscosity value will be 16.96 into 10 power minus 6 meter square per second. This is the unit. So other things, these three required, support density required and other things now that also will write. So now not required this all the values. So now all the properties I wrote at the 40 degrees Celsius. 60 plus 20, 80, 80 by 2 is equal to 40 degrees Celsius. So at the 40 degrees Celsius, I wrote the all the values. Now check the status of the fluid. So Reynolds number value will be U, formula writing UL by nu. So U will be how much given? 3. L how much given? 2. And kinematic viscosity 16 into 9, 6, 10 power minus 6. This value is coming, already we calculated. This value is coming, Reynolds number value is coming 35.377 into 10 power 4. This value is 35.377 into 10 power 4 less than 5 into 10 power 5, which is laminar flow. What is this one? We know the laminar flow. So this value I know the laminar flow. Now see here, this work out we have to do each and every problem, status of the fluid, laminar or turbulent. Now once I know that laminar flow for given flat plate laminar flow, these are the steps 1, 2, 3, 4, Q. So first local Nusselt number. So Nusselt number H nu x, this is a symbol. So directly we'll substitute the formula value 0.332. Reynolds number will be 35.377 into 10 power 4 power 0.5. Then Prandtl number 0.699 power 0.333. So this Nusselt number value is coming 175.27. Then again this Nusselt number value, what is formula? Hx by H, local heat transfer coefficient, length by K. If you substitute there, Hx we need length 2 meter, then K value will be 0.02756 into 10 power minus 3. So we'll get here Hx. We'll get here the Hx value. So 127.27, so this will get the Hx value will be 2.415. Unit will be watt meter square Kelvin. Hx we know. Now up to this over Hx we know. Now average heat transfer coefficient. Step 3 what is? Average heat transfer coefficient H is equal to 2 into Hx. So 2 into 4.1, 2 into Hx value how much we got? 2 into 415. So 2 into 415 is equal to 4 point something will come, 4.83. That also unit will be same, watt meter square Kelvin. Now substitute in the Q. 2 into H, average heat transfer coefficient, TW minus T infinity. So 2 into H now, HA. So what is HA? So H value how much? 4.83. Then area will be width into length. So length will be 2 meter, width is given unit width 1 and 60 minus 20. So this value will come, Q will come 386.4. 386.4 watts will come. So this way we can calculate the heat transfer per unit width. So look here, steps. Up to this this question they are asking. So look again. Once the questions given, first we'll see the which type of convection, forced convections and natural convections. Velocity given, this is the forced convection. These are the steps, film temperature, then status of fluid, Reynolds number. So less than coming na laminar flow, flat plate given. This is the formula. We substitute all the value, we will get the heat flow. If in the same question they will ask, find the hydrodynamic boundary layer thickness, thermal boundary layer thickness, local friction coefficient thickness, average friction coefficient. So these are formula is there in the data book. 5 into x into Re minus 0.5. Thermal boundary layer thickness, the same. The hydrodynamic boundary layer thickness into Prandtl number power minus 0.333. If local friction coefficient 0.664, Reynolds number power minus 5. Average friction coefficient, this. Only see the Reynolds number, Prandtl number and this hydrodynamic boundary layer, this value substitute. Whatever they are asking, either hydrodynamic boundary layer, thermal boundary layer, local local friction coefficient, average friction coefficient. These all the are only for the laminar flow. for the laminar flow, then if the last, this is formula for the laminar flow, flat plate laminar flow. This all the formula will be there in the data book. So only you have to substitute the value, will get the answer. So, okay, so you should understand the process how to find. Okay, okay students, we'll go the number of problems future. These steps, if you remember, varieties of problems will solve for the force convections, laminar flow, then turbulent flow, then we'll go the natural convections. Okay, force convections first problems will solve. Okay, okay students, watch this video, subscribe the channel those still not subscribed, and share this video to friends so they can get the maximum benefits. Okay, thank you students.